Hello everyone, my name is Denisha Blair and I'm a grad student at Florida State University. The topic of my presentation is a toolkit for bulk fluxes, the modularized flux testbed. Bulk flux parameterization are used when direct observation of fluxes, for example, eddy covariance fluxes, are not available. They are used in model. They are tuned to eddy covariance observation. Bulk flux models use the following variable listed here to determine fluxes. The bulk flux model also parameterizes transfer coefficient or a roughness length. So there are a lot of different ideas about how transfer coefficient and roughness length should be parameterized. So these ideas can be explored using a flux toolbox known as the modularized flux testbed or also known as the MFT. Here is an example showing how fluxes are associated with oil spill. The figure shows that having oil on the surface, the friction velocity will decrease, which can decrease latent heat and sensible heat, which in turn can impact the transport of the surface oil. So MFT allows me to investigate the effects of oil and water separately on fluxes and how those impact the transport of the oil. The MFT allows users to select a wide range of parameterization from selected paper. So it is very easy to add new options to the MFT because the code is nicely modularized, and the user can also mix and match roughness, length, and stability parameterization, adjust observation of wind, temperature, and humidity from one height to another height, and use a wide variety of input. For example, instead of wind, the input could be stress, friction velocity, or neutral equivalent wind. So the 2021 version allowed the user to set a value of stress and boundary layer stability and calculate the fluxes. So the 2021 version is better tested and programmed and is written in Python. And this version of the code will be added to Dr. Barrasso website later this fall. So the 2019 version of the MFT was written in C, but had a subroutine written in other languages that could call the C program, for example, Fortran, Ideal, and MATLAB. Here are some examples from my research where I used the MFT to compute the drag coefficient with respect to variation of fractional oil coverage while controlling the input variables of air-sea temperature differences and wind speed. So A oil is the fraction of oil coverage on the ocean surface, and the figure shows that the presence of oil on the ocean damps the capillary waves and the short gravity wave, which reduce the drag coefficient, which in turn impact the surface ocean current. For my research, we use a modified version of the Barrasso-Vincent wood surface roughness length parameterization to take the oil features into account due to oil and water having different surface roughness. So this version of the BVW parameterization was easily incorporated into the MFT, where all these variables in the BVW can be controlled, in other words, turned on and off in the MFT. Here's another example where I use the MFT to compute the changes in surface stress due to wind speed and due to stability. And the figure shows that the changes in stress due to wind are very correlated to the changes in stress due to stability. And one of the conclusions is that the changes in stability is mostly due to the changes in air temperature. And this was a surprise since most people assume that the air temperature won't change more than the SSD. In conclusion, the MFT is very user-friendly and the code is nicely modularized, so therefore we hope to have the 2021 version of the MFT available this fall. And thank you all for listening.